Good morning, students. Today we are going to discuss the next three sums of the chapter probability. The exercise that we are going to discuss is exercise 15.1. So, the next three sums means question number 4, 5 and 6. In question number 4, the question is like this. 3 coins are tossed simultaneously 200 times with the following frequency of the different outcomes. So there are 4 different outcomes: 3 head, 2 head, 1 head and no heads. And the total frequency, total number of time the coin was tossed was 200 times. And the outcomes are of the individual outcomes are like this. For 3 heads the frequency is 23, for 2 heads the frequency is 72, for 1 head the frequency is 77, and for no heads the frequency is 28. We have to find the probability that the 2 heads coming up. So let us see how to solve this sum. So the number of coins, the number of times the coin was tossed, total number of tosses was 200. And in the question you can see that head occurs 72 times. If we go back to the question, you can see that head occurs 72 times. So our number of times 2 heads occurs is 72. So the probability of 2 heads coming up is 72 by 200, which is equals to 9 by 25 after simplification. So 9 by 25 is our answer for sum number 4. Now let us see the sum number 5. It is a big sum and it is also a very important sum. In sum number 5, an organization selected 2,400 families at a random and surveyed them to determine the relation between the income level and the number of vehicles in the family. The information gathered is listed below. This is the information. If the monthly income is less than 0, the families owned 0 vehicle is 10, 1 vehicle is 160, 2 vehicle is 25 and above 2 vehicles is 0. So this column is our monthly income of the family, and this column vehicle per family, how many vehicles does the family have? 0, 1, 2 or above 2. So from this table we have to find the following subparts. The following subparts that we have to find are the probability that the family chosen earning 10,000 to 13,000 per month owning exactly 2 vehicles. Then earning 16,000 or more per month owning up to exactly 1 vehicle. Then earning less than 7,000 per month and does not own any vehicle. So we have to go through each of the numbers in the table and then find out the answer. So let us see. The first subpart says the family should earn 10,000 to 13,000 and owns exactly 2 vehicles. So let us see. In this table, the table is I am showing over here is the same table as the question, only the number is highlighted. So let us see how this sum is being done. So from the table we can see that 10,000 to 13,000 is this slab, and the family which owns exactly 2 vehicles is 29 families. So you can see the number of total families surveyed that was given in the question is 2,400, and the number of families earning 10,000 to 13,000 per month owning exactly 2 vehicles are 29 only. So 29 is the number, that is number of families that owns exactly 2 vehicles. So the probability will be 29 by 2,400. So that is what it is written. 29 by 2400. Now it cannot be simplified as 29 is a prime number. So the answer is 29 by 2400. Now let us see to the next subpart. In the next subpart, the question says, find the probability that the family chosen is earning 16,000 or more. 16,000 and more is this slab, and per month, and owning exactly one vehicle. Owning exactly one vehicle is this column. Is 579. This number of family owns exactly one vehicle who are earning more than 16,000 or more. So total number of family is 2,400, and the number of family earning 16,000 or more per month owning exactly one vehicle is 579. So the probability will be 579 by 2,400. Now subpart 3. In subpart 3, the question says find the probability that the family chosen is earning less than 7,000. Less than 7,000 is this slab per month and does not own any vehicle. So 0 is the number, that is 10. So no vehicles, family earning less than 7,000 are 10 such families. So number of families first, total number of families surveyed is 2,400, and the number of family earning less than 7,000 per month and does not own any vehicle is 10. Hence the probability will be 10 by 2,400, which is 1 by 240. Now subpart 4. In subpart 4, it is asked, find the probability that the family chosen is earning 13,000 to 16,000 per month. 13,000 to 16,000 per month is this column, this row, and owning exactly more than 2 vehicles. So they are earning above 2 vehicles, which they are having above 2 vehicles, which is 25. So total number of families surveyed is 2,400. Number of families earning 13,000 to 16,000 per month and owning more than 2 vehicles is 25. Hence the probability will be 25 by 2,400, which is equals to 1 by 96. This is subpart 4. Now the last subpart. Last subpart says, find the probability that the family chosen is owning not more than one vehicle. So total number of family is same, 2,400. But how many families are owning not more than one vehicle means they are not owning 2 vehicles or above 2 vehicles. They are owning either no vehicles or one vehicle. So this full part has to be added. And since the income is not stated, so all the income has to be considered. So the number of families owning not more than one vehicle is equals to number of families owning 0 vehicles, this full column, and the number of families owning exactly one vehicle, so this full column. If we add them up, we will get 2062. So find the probability. So the required probability will be 2062 by 2400. If we simplify, we will get 1031 by 1200. So this is how the probability is done. And this question number 5, is very, very, very important. Now let us see question number 6. In question number 6, it said that a teacher wanted to analyze the performance of 2 sections of a student in mathematics test of 100 marks. Looking at their performances, she found out the few students got under 20 marks, few students got above 70 marks and above. So she decided to group them into the interval of varying sizes as follows: 0 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to above. Now this is an class size, there is no uniformity. The first class size is 20, rest all these class size is 10, and the last one is 30. So the class size are different. Okay, now that does not bother with our answer in probability. Now there are two subparts to this question. The first subpart said, find the probability that the student obtained less than 20% in a maths test. So less than 20% in a maths test. Less than 20% in a maths test means the number is less than 20. Less than 20 means this slab. So number of student is 7. So let us see how it is done. Total number of students is given 90. If you come back to the question, you can see the total frequency is 90. So total number of students is 90. Number of students obtained less than 20 marks is the students who got in the interval 0 to 20, which is 7. So the probability that the student obtained less than 20 marks is 7 by 90. So this is our first subpart. Second subpart said, find the probability that the student obtained marks 60 and above. So let us come back to the question first. 60 and above means this two column. If the upper limit is 60, that means we are not considering the number 60. We always leave out the upper limit. So from 60 and above means this column of 60 to 70 and 70 to above. So we have to add these two. 15 plus 8 is equals to 23. So let us see how the sum is done. Yes. So total number of students is 90. Number of students who obtained 60 and above are the students who have 60 to 70 marks plus the student who have 70 and above marks, which are 15 plus 8, which is equals to 23. So the probability that the student obtained 60 and above, 60 to 100, is 23 by 90. Now again 23 is a prime number, so we cannot simplify. So the answer is 23 by 90. So this was question number 6. I hope this short tutorial of sum number 4, 5 and 6, of which sum number 5 is very important, and that is the kind of sum that usually comes in exam, is helpful for you. Thank you.